Hi, welcome back to our video series, Process Automation with Netfabb. In the last video, we have learned how Lua scripts could be used to automate entire processes. Now, we want to go one step further and show you how you can create custom applications using Lua scripts. This is level 3. Before we talk about the examples that I've prepared, let's take a closer look at possible implementations of Lua. First, where can we use Lua? Most scripts, like the ones that we have seen so far, the part labeling, are used in the main menu. We've already seen that. However, we have also the possibility to create scripts for the slice commander, for example, that refer to the layer stack format. The same applies to the selective space structures module 3S, which allows us to control very precisely how we can link lattice structures to the part. Another very important question is, how do we want to implement the script? Here we have the possibility to create semi-automatic scripts as well as fully automated ones. That means we can control if we want to enable user input. This comes very handy when you want your users to select which support script, for example, they want to use. For this, Lua offers the possibility to develop your own menus and user interfaces. If we work fully automatic, we should even consider if we want to start the script from the user interface, or if we want to avoid it by calling the script from the command line. This makes the handling very easy and versatile, especially when used in a server environment. In the following example, I would like to address an often tiresome issue in 3D printing. The impeller that has been with us for quite some time now should now be printed. Now, it's the case that the impeller is not necessarily an easy application due to its thin-walled areas that are below or very close to our critical angle. If you were now to optimize the process and increase the part quality, you would have to work on the machine side. You would have to find the perfect exposure parameters, such as the classics, laser power, scan speed, hatch distance maybe, that are typically provided by the machine OEM. You would have to find them, adjust them so that they fit the part better. Basically, you would have to set up your design of experiment to get a better impression of how the part performs under process circumstances. In Netfabb, we can solve this manually by, first of all, slicing the part. We are now in the Slice Commander module. Here we can use the sliced part geometry to add exposure elements such as contours and infills. Let's just take a single contour and a simple hatching for this part. After creating the exposure elements, we see them in the tree on the left side. The exposure elements now receive their corresponding properties such as laser power and mark speed or scan speed. We can now provide the values that we want the machine to use later on for the actual exposure of the part during the 3D printing process. So as we can see, this might turn out to be a very long and above all very error-prone process in the end. So how can we now simplify this issue? We start again with the slicing of the component. After checking the slices, we're not going ahead and creating our exposure elements manually, but we are going to run and execute a Lua script that I have prepared up front. Interestingly, the first thing that a Lua script does is it's asking us to read a CSV file. Thereupon, our slices are copied several times. So what happened here? What basically happened is that the script created a parameter study. The CSV table that we have applied in the first step of the script execution serves as the input criteria for our parameter study. For each line in our file, the script creates a copy of the part and links it to the exposure parameters in the columns. So by that, we can easily and quickly set up a complex material study with many different iterations and combinations of parameters. Let's have a look at one more example. The folder that we're seeing right now contains a Netfabb project that I want to use as a template. This template could contain any kind of test specimen, for example, that I want to include in every one of my build jobs. What I have as well is a batch file, a .bat, in which I will call Netfabb. And when I call Netfabb, I also want to start Netfabb using a Lua script that I've also specified out of the same folder. The /terminate after Lua means that Netfabb should close itself after it has finished the operation. Now you could either copy this line into your command line or start the batch file with a double click. After starting the script via batch file, Netfabb is going to open our template build job. It is going to add a part geometry and do the entire build preparation that we have specified in the Lua script for that particular part. So we have seen that a part has already been added, a part has been oriented, a support script has been executed, and what happens now is that the script is also slicing the geometries, and after slicing, it is also going to export the part into the dedicated machine format. Here we can see how the system is currently outputting the file into the machine-specific .slm file format that is based on the machine configuration that is also specified in the script. As soon as the script has finished, we are getting a log file in our folder that gives us an indication about all the different layers that we have just created. And additionally, we also get our .slm file, the exported file that we can also open with Netfabb and double check if all the slices, if all the layers have been processed in the way that we wanted it. To conclude this topic, here are once again the main aspects. So we have the possibility to access nearly all Netfabb functions in Lua. Furthermore, we have the possibility to also work with tables, screenshots, and even reporting functions. The scripts that we develop can be used variably and can be called either semi or fully automatic, also via the command line, as we've seen in the last example. This was the last video in our video series, Process Automation with Netfabb. Please get in touch if you want to learn more or get access to these additional resources right here. Thanks for watching.